Chapter 8-3 notes solve systems of equations by elimination or by the addition method, either one. In example 1, the first line is x plus y equals 5, and the second line is x minus y equals 1. If we use the addition method or elimination method, we're going to add going down, and we notice that x plus x is 2x, and positive y and negative y is 0, equals 5 plus 1 is 6. So we divide by 2, so 2x equals 6, divide by 2, and you get x equals 3. Okay, that only gives us one part of the point of intersection. That gives us the x part. We now need the y part. So you're going to plug it in either to the top or the bottom. It doesn't really matter where you plug it into. So for now I'm going to do the x plus y equals 5 because that seems a little bit easier. But it really actually doesn't matter. You'll come out with the same answer. So I'm going to put 3 in place of the x. So 3 plus y equals 5. And then we're going to subtract 3. And y equals 2. So the y coordinate is 2. So the point of intersection for these two lines is at 3, 2. Example 2, the first line is 3x minus 3y equals 6, and the second line is 3x plus 3y equals 0. Okay, it looks like the y's are going to cancel out. So 3x plus 3x is 6x. 3y minus 3y is 0. And then 6 plus 0 is 6. So 6x equals 6, divide by 6, and you get x equals 1. Okay, so that's the first part of our point of intersection. Okay, plug it into the top or to the bottom, it doesn't actually really matter. I'm going to plug it into the bottom because it's all plus, so I'm going to put it in here. So that's 3 times 1 is 3, plus 3y equals 0. Subtract 3. 3y equals negative 3. Divide by 3, divide by 3, and you get y equals negative 1. Okay, so the y part is negative 1. So the point of intersection is at 1, negative 1. Okay, example 3, 8x plus 11y equals 37, and negative 2x plus 11y equals 7. Okay, if I add going down, this is not going to cancel out, because they're both positive. One has to be positive and one has to be negative, and it has to be the same number for them to cancel out to 0. Okay, so I think the easiest thing to do would be to multiply either the top or the bottom by negative 1. If I multiply the top or the bottom by negative 1, then that will give me, this will become a negative y, negative 11y, and then it can cancel out. So let's see what happens with that. So negative 1 times negative 2x is positive 2x. Negative 1 times 11y is negative 11y. And negative 1 times 7 is negative 7. And on the top we still have the same thing. We still have 8x plus 11y equals 37. Okay, so now we can add, because it looks like the y's are going to cancel out. 8x plus 2x is 10x. Okay, the y's cancel out because 11y minus 11y is 0. Okay, and then equals 37 minus 7 is 30. So 10x equals 30. Divide by 10, and x equals 3. Okay, so that gives me part of my point of intersection, 3. I need the y coordinate, so I'm going to plug it back in. Take the 3 and I'll just put it in here. That's what x equals 3. So 8 times 3 is 24. 8 times 3 is 24, plus 11y equals 37. So all I did was take the 3 and put it inside the x right here. 8 times 3 is 24. Okay, then we're going to subtract 24. We get 11y equals 13. Divide by 11, and you get a fraction. And I don't really feel like dividing that on the calculator, so we're just going to leave it y equals 13 over 11. And over here we'll just put y is 13 over 11. So that's the point of intersection for these two lines. Okay, example 4 is 3x plus 6y equals negative 6. And the second line is 5x minus 2y equals 14. Okay, we're going to try to cancel out one of the letters, either the x's or the y's. It looks like this one's already positive 6, and this one's negative 2. So one's positive, one's negative, so that's good, except they're not the same number. So I want to try to make a negative 2 into a negative 6. So to do that, I'm going to multiply everything by 3. Because if I multiply everything by 3, that will become a negative 6y. Okay, so now what do I have? Let's see, I have 15x minus 6y equals 42. And on the top I still have 3x plus 6y equals negative 6. I'm going to add going down. Okay, 3x plus 15x is 18x. And then the 6y minus 6y is 0. And negative 6 plus 42 is positive 36. Okay, so 18x equals 36. Divide both sides by 18. Divide by 18. And get y equals 2. Okay, so that gives me my y coordinate. I need the x coordinate. Okay, so now I'm going to take it and plug it in to, I say let's take it and plug it into here. Alright, so now we have 3x plus 6 times 2. So 6 times 2 is 12. Equals negative 6. Okay, then I'm going to subtract 12. 3x equals negative 18. Divide by 3. Divide by 3. And x equals negative 6. Okay, my mistake. X equals 2. X equals 2. So, okay, I'm going to plug in the x equals 2 in here. Okay, so now that's 3 times 2. 3 times 2 is 6. Plus 6y equals negative 6. We're going to subtract 6. We get 6x equals negative 12. And x equals, 6y equals negative 12. Y divided by 6 divided by 6. Oh, this problem is flustering me a little bit. Okay, negative 12 divided by 6 is negative 2. So my y coordinate's negative 2. So point of intersection is at 2, negative 2. This is the x, this is the y. Alright. Okay, example 5 is the hardest one. 5x plus 3y equals negative 2. No, sorry, that's equals 2. Let me make that a little clearer. Equals 2. And 3x plus 5y equals negative 2. Now on this one, it's a little harder to see what's going to cancel out. In fact, I can't do anything to the bottom to make it equal 5 or get rid of the y's with a 3 and a 5. So, okay, so what I'm going to do is I'm going to multiply. I'm going to have to do both equations. I'm going to change both equations. So I'm going to multiply this by 3 because that gives me 15x. And I'm going to multiply the bottom by negative 5 because that will give me negative 15x. So now I can cancel out. So you kind of had to do something to both equations. So on the top I have 15x plus 9y equals 6. And on the bottom I have negative 15x minus 25y equals positive 10. Alright, now we can cancel out. The 15x minus 15x is 0. And then we have 9y minus 25y is negative 16y. And 6 plus 10 is 16. Divide both sides by negative 16. Divide by negative 16. Divide by negative 16. You're always going to divide by the number attached to the variable. Negative 1. Okay, so we have the first part of our intersection. Okay, now we're going to plug it back in to one of the equations, the original equation. So let's take this y equals negative 1 and put it in here. Okay, so now I have 5x, and 3 times negative 1 is negative 3 equals 2. Okay, then we're going to add 3. 5x equals 5. Divide by 5 and you get x equals 1. So the point of intersection is at 1, negative 1. Alright, example 6. Negative 2x plus 3y equals negative 6. 2x minus 3y equals positive 6. If you notice, everything cancels out. That's 0, that's 0, that's 0. So what we have is 0 on the left side equals 0 on the right side. And when that happens, when you get 0 on the left side equals 0 on the right side, it's infinite solutions. That means it is a line. The first line is sitting on top of the second line. So it's basically the same line twice. So infinity is the solution. It has an infinite number of solutions. Okay, let's look at example 7. The first line is negative 2x plus 3y equals 7, and the second line is 2x minus 3y equals 6. If we add again going down, we notice that, okay, this is 0 and this is 0, but this on the right side is not 0. So we have on the left side we have 0, and on the right side 7 plus 16 is 13. Well, 0 is not equal to 13. 0 does not equal 13. So this is no solution. That means both of these lines are parallel. So this is the same line twice. And these are parallel lines. That means they never meet, and that's why they have no solution.